Good day, class. In this video, I will going to discuss about the motion problem. But before the discussion proper, we will answer first the last problem for the digit problem. I forgot to include this one from the previous video. So we will answer uh, this problem in this video. Okay. So we have a number of two digits divided by the sum of the digits. The quotient is 7 and the remainder is 6. If the digits of the number are interchanged, the resulting number exceeds 3 times the sum of the digits by 5. So what is the number? Our answer for this problem is 83. Now our goal is to verify if this is true. Okay, so for this problem, we are going to expect a two-digit number. So we're going to let u. This is for our uh, units digit or ones digit, and then we're going to let t as our tens digit. Okay, so um, our requirement or what is asked in the problem is the number itself, so it is written by tu, so it is written in this way, starting with the tens digit followed by the ones digit. So solution. Now, as what I have told you from the previous video, that in solving a digit problem you need to generate a working equation from every sentence that is present in the problem. So let's start uh, by interpreting the first sentence. So the first sentence states that a number of two digits divided by the sum of the digits, the quotient is 7 and the remainder is 6. Now we have a concept here that is we're going to divide the number with a remainder. So if we're going to implement this one first with some known values without um, without having without having um, the variables. So let's say for example, if you would like to divide 5 by 2, so this is how it goes. So 5 divided by 2, so the answer is 2, and then we have the remainder 1. Now, if we are going to express this one in equation form, no, without having this r, so that would be 5 all over 2. This is simply equal to the answer of the division, or that is our quotient, plus the remainder on the numerator, so it would be 1 over the divisor, which is our 2. So this is how we are going to create an equation in dividing a number with a remainder. So we are going to use this one in order to generate our working equation from sentence 1. So we have the given number. So the given number, since it is in number form, so we are going to um, write this tu in its expanded form. So the expanded form is we multiply 10 by the tens digit plus u, and then from sentence number 1, we are going to divide the number by the sum of the digits. So the sum of the digits is t plus u. And then the quotient, so we are already finished for this part. So equals the quotient. So the quotient is 7 plus, okay, so the remainder is 6. We're going to put 6 in the numerator, and then we are going to write the divisor on the denominator. So that would be t plus u. Okay, so this is our working equation for the first sentence. Now we are going to um, simplify this one. So we're going to eliminate the fraction by multiplying both sides of the equation by t plus u. So we're going to distribute this one. So on the left side, what's left is 10t plus u because the denominator will be cancelled out. Then 7 times t plus u, so we have 7. Since the operation is multiplication, do not forget to enclose t plus u with parentheses. So t plus u and then plus. So here the denominator is the same with our multiplier. So these two will cancel out. What's left is only the numerator, which is 6. Then after that, um, let's modify this one further, or let's simplify this one further, because this 7 can be distributed to each of the terms inside this parenthesis. So that would be 10t plus u is equal to 7t plus 7u plus 6. Next is we are going to put all the variables on the left side and then the constant on the right side of the equation. So let's do that. So we're going to transpose 70 to the left side and also 7u to the left side. So we have 10t minus 7t plus u minus 7u is equals to 6. So next we have 3t minus 6u is equal to 6. Now 3 is a common factor to each of the terms in the equation, so I guess we can multiply both sides by 1/3. So we have t minus, so 1/3 times 6, that would be 2u is equal to 2. So this will be our equation 1. Now as you can observe, we have two unknowns here, the units digit and the tens digit. And right now, we only have one equation. So in order to solve these two unknowns, we need one more equation in order uh, to solve these unknowns. So we will proceed to the second sentence. So the second sentence states that if the digits of the number are interchanged, the resulting number exceeds 3 times the sum of the digits by 5. Now, um, we have a word here, exceeds. So in mathematical um, concept, exceeds means that that is the uh, excess after subtracting the two numbers or the two um, variables. So this exceeds is somewhat related to the subtraction operation. Okay, so if the digits of the number are interchanged, so if the two digits are interchanged, so the ones digit will be the tens digit, and then the tens digit will be the ones or the units digit. So if we're going to write that one in equation form or in expression form, that would be 10u plus t. So notice we interchange the placement of the units digit and the tens digit. So we do the reverse of these digits. Next, the resulting number exceeds 3 times the sum of the digits by 5. So meaning, after we reverse the number, we found out that this reverse number is already bigger in value compared to the original number by an amount, by a magnitude of 3 times. Okay, by a magnitude of 3 times. So therefore, since we have a word exceeds, so as what I have told you earlier, this is somehow or somewhat related to the subtraction operation. So we're going to use minus 3 times, okay, exceed 3 times the sum of the digits. So the sum of the digits uh, is represented by the expression t plus u. Okay, so again, uh, t plus u, this one represents the sum of the digits. Now, the reverse number, so this is our reverse number, minus 3 times the sum of the digits. The answer is 5. Okay, because this is the magnitude of the subtraction operation that happens for the second sentence. Okay, so again, um uh these two expressions right here, this is for the reverse digit of the number. Okay, and then this one is um the magnitude. Okay, this 3 came from these two words 3 times, and then the sum of the digits, so we have t plus u, then the answer is 5. Now we are going to simplify our second equation, so that would be 10u plus t minus, so we're going to distribute this one, do not forget the negative sign, so 3t minus 3u is equal to 5. Then combine like terms. So we have 10u minus 3u, so that would be 7u. Then we have t minus 3t, so that would be negative 2t is equal to 5. Now we are going to um, modify this one so that the arrangement of this second equation will be the same with the first equation. So in our first equation, um, we started with the variable t. So let's do the same thing to our second equation. So let's start with negative 2t, then plus 7u is equal to 5. So this will be our um, second equation. Next, since we have these um, two equations, so um, let's proceed to the next slide. So this is our equation 1. Again, that is t minus 2u is equal to 2. Then our second equation is negative 2t plus 7u is equal to 5. Now, there are lots of ways in solving these two system of linear equations. Now, you can use your scientific calculator. So this one, let me show you how it is done. To go to mode, then choose 5, and then choose 1. This is for two equations, two unknowns. Then input the coefficient of the variables. So for t, we have 1, then negative 2, then the constant is 2. So make sure that the constant should be on the right side. Sorry. Okay, then equals. Next we have negative 2, then 7, and then 5. So our t is 8, and then our u is 3. Okay, so we have t is equals to 8, then our u is equal to 3. So therefore, the number is 83, and it is indeed correct. Now, let me show you the second step. or the second method in solving these two unknowns. So let's start with the first equation. So we're going to solve the variable t here in terms of u and the constant. So to do that, we're going to transpose this one to the right side. So we have t is equal to 2 plus 2u. Next, we are going to substitute this expression, no, for t to the second equation. So we have negative 2. So replace t with 2 plus 2u, and then plus 7u is equals to 5. So can you distribute the negative 2 to each term inside the parentheses? So that will be negative 4. Okay, not positive but negative. So we have negative 4u plus 7u is equals to 5. So combine these two, that would be 3u. Then transpose this one to the right side. So you have 5 plus 4. So 3u is equals to 9. Divide both sides by 3. So you have u is equals to 3. 9 divided by 3 is 3, which is the same with the answer from our scientific calculator. Next, once we have the value for our u, now we're going to use this one, substitute this to the first equation in order to solve for t. So we have t is equals to 2 plus 2 times the value of u, which is 3. Then simplify this one. So you have 2 plus 6. Therefore, t is equals to 8. So we still arrive the same answer from our answer from the calculator. Okay. So next, we will proceed to our discussion proper for motion problem. So by the end of this lesson, you'll be able to apply all the basic concepts in algebra in solving motion problems. So this is how you are going to analyze a motion problem. So we have here a car that travels on this uh, straight pavement. Okay, so let's assume that this car covers a distance represented by this small letter d. That is, this car travels from this point, say point A, up to this point, point B. And of course, aside from the distance, so it also covers a particular amount of time. And we're going to represent that one as t. Again, this small letter d is for the distance. And then this one is for the time. Okay. So the rate of change of the distance with respect to time is known as speed, or in physics that's velocity. So the only difference for speed and velocity, speed does not have any direction, whereas velocity has a direction. So that is why velocity is a vector quantity, whereas speed, that is a scalar quantity. Don't worry, you will learn that one when you are going to um, enroll your physics subject. Okay, so let's go back. Another definition for speed. Okay, again, this one we're going to use this to represent the speed, or it could be the velocity of the car. Speed or velocity, in some cases, uh, it means that this is um, the quantity that measures how fast our um, vehicle, or how fast a thing travels, no, at a particular distance and at a given period of time. Now, for our motion problem, we're going to assume that the object here, no, which is our car, is moving at a uniform rate, or at a constant velocity or speed. So if it moves at a constant velocity, therefore we don't have any acceleration. So acceleration means that this is the rate of change of your speed or velocity at a particular um, time. Now, how are we going to relate these three variables, the speed, the distance, and the time? So we're going to use this working formula in which speed, represented by v, or this is also known as the rate of change of the distance over time, is equal to the quotient of the distance d and the time t. So this is very um, powerful formula in solving motion problem. Now we have another concept here for motion problem. This one is very common in motion problems. So we have here the average speed. So the average speed is given by this formula: v average is equal to the total distance traveled over the total time of travel. Now, I included this one because there are some students who might be careless sometimes in analyzing motion problem. Now, I have here an example. Let's say we have an object that travels from A to B and then to C. Say, for example, um, from A to B, the object has a speed, say v1 is equals to 3 kilometers per hour. Okay, and then the distance from A to B is, let's say this is d is equal to um this one is like okay, let's uh let's just change this one, no? Or I guess let's just stick to the value there. Sorry, let's stick to the 3 kilometers per hour. So let's say the distance here is 1.5 kilometers, and then from A to B, the time it takes for this object to travel is, let's say, 2 hours. Then from B to C, its average speed is, let's say, 2 kilometers per hour, which is a bit slower compared to uh, the first average speed from A to B. Then the distance from B to C is like 2 kilometers. Then the time here is, let's say, 1.5 kilometers. Now, if the question states that what is the average speed from traveling in traveling from A to C, there are some students who answer this problem in this way, like the average speed is simply equal to the average of the velocities from A to B and B to C. So they do this in this way: v1 plus, sorry, this one is v2 all over 2. Okay, which is incorrect because the definition of the average speed is that you need to determine the total distance traveled for a particular trip. So our trip here is from A to C. That is, you need to sum up all the distances that are being covered for the entire trip. So that would be D1. Okay, this, let's say we're going to represent this one as D1 and D2, then this one is D1 and D2. So it must be D1 plus D2. So this is the total distance traveled for the entire trip, and then over the total time of traveled for the entire trip, and that is T1 plus T2. So this is how the student must solve the average speed, not this one. Okay, do not add the given average velocities for the entire trip. Another thing to note for motion problem is this one. So there are some cases that an object is moving with or moving through a given medium. It could be an air or water. So if the object is moving with the fluid flow, so your clue here is moving with, so along with the fluid flow. It could be wind or water current. As you can see in the figure on the right side, so we have an airplane, and then we have uh, a wind that blows from the rear part of our airplane. So we have a wind velocity that blows from the rear part of the airplane towards the front. Now, the resulting velocity represented by Vr is equal to the sum of the wind speed represented by V subcurrent and the speed of the airplane represented by V sub object. So why we need to add this one? Because the direction of the wind speed matches the direction of the uh, airplane. Now, the second case, if the object is moving against the fluid flow. So as you can observe in our figure, the wind speed, the direction of the wind speed is against the direction of the airplane. So it will take a much longer time to travel in this case because um, the wind speed slows down the resulting velocity of our airplane. That is why the resulting velocity for this case Vr is equal to the difference of the airplane's speed and the wind's speed. Okay, so this one will not only be applied for airplane, it can also be applied for a ship that is sailing on a rough sea, or a boat that is moving on a river. So it could be against the flow of the river or along the flow of the river. Okay, now let's have our uh, first example for motion problem. So we have here jogger A and B starting from the same point, jogging in opposite direction in a circular path. So we have here a circular path. Their circular path has diameter of 800 meters. So this one measures 800 meters. Now for motion problem, make sure to be familiarized with the conversion units, especially for um, unit of distance and unit of time. So for distance, you have the SI unit, meters, it could be in kilometers or in centimeters. Then you have the imperial units or English units, it could be foot, could be yard, inch, furlong, what else, miles, nautical miles, so on and so forth. So be familiarized with the units. And for speed, you have the kph, or that is kilometers per hour, or it could be miles per hour, feet per second, meter per second. So be familiarized with the conversion units. So next, we'll continue. So if the average speed of jogger A is 3 kilometers per hour and that of jogger B is to be 4 kilometers per hour, compute the time they will meet. Now, in analyzing emotion problem, make sure to start your solution by illustrating the problem, just like what I have here in my slide. So I draw a circular path. So this red dot represent the starting point of these two joggers. We have A and B. Now, if you're going to analyze the problem, these two joggers start at the same point and then they jog in opposite direction. So let's say jogger A goes in this direction, then jogger B goes in this direction. Okay, that is they jog in opposite direction, and then at some point of time they will of course meet because this one is a circle, so there's an intersection point, no, between them. So there's an intersection point wherein they will going to meet with each other. So I represent that one by this second red dot. So this is the finish. Okay. So next, after you have your illustration, next is, of course, you're going to write the given. So from the problem, uh, we have a diameter for our circular path that is equal to 800 meters. So we can represent that one by capital letter D, that is 800 meters, or that is also equal to zero point 0.8 kilometers. Now, I prefer to use zero point 0.8 kilometers. It's because this unit is consistent to the unit of our speed, which is in kilometers per hour. Okay, so we're going to use the kilometer unit instead of the meter. That is why uh, I've just converted this 800 meters into kilometers. Next, we are going to represent the speed or the average speed of jogger A by V sub A. So in the problem, that is 3 kilometers per hour. So 3 kilometers per hour. What else? So jogger B has an average speed also. So we're going to represent that one by V sub B. That is 4 kilometers per hour. Now, the requirement for this problem is that we are going to compute the time they will meet, and we're going to represent that one by small letter t. So solution. Now maybe some of you will just use the basic or the basic working formula for motion problem. Well, that is not really the case because you can only use those working formula, no, as your foundation in solving motion problem. Now, the idea here, in order to come up the right answer, is simply same to what we did from the previous types of problems. We are going to generate a working equation. So how are we going to generate a working equation for motion problem? So for motion problem, for most cases, you are going to base your working equation from your illustration that you have just created. That is why if you don't have an illustration or a diagram, then you cannot generate a working equation. Okay? Now, let's focus to our illustration. So this is our illustration. Jogger A and B start the same point, and then at some point in time they will meet. No, they will meet throughout their journey along this circular path. Now, if you try to analyze the distance covered by jogger A from start to finish plus, okay, this is the distance covered by jogger A plus the distance, okay, we're going to let that one as dA, plus the distance covered by jogger B, that is dB. Now, if you try to observe, the sum of their distances is just simply equal to the circumference of this circular path. Now we are going to um, translate that one in mathematical statement. So that would be um, distance covered by jogger A plus the distance covered by jogger B is simply equal to the circumference of the circular track. So that is dA plus dB is equal to um, pi d. So this is the formula in calculating the circumference of a circle. Next, now when you are generating a working equation, make sure that in your working equation it must contain the variable that uh, that is asked in the problem. Okay, so uh, the requirement for our problem is t, so t must be in the working equation. But as you notice, we only have dA and dB. So therefore, we are going to use this time the working formula for motion problem. We all know that the speed is equal to the distance over time. So therefore, since in our working equation we have here the distance variable, so therefore we're going to modify this one. So distance is simply equal to the product of the velocity and the time. So for jogger A, its distance can be expressed in terms of its velocity and the time it takes to travel from start up to the finish. So that would be VA times T and then plus. So for jogger B, that is VB times T is equals to pi D. Now, maybe you are a bit confused why both joggers have the same time, no? Of course, since they start um, at the same time, so they will also meet at the same amount of time. That is why I just simply represent t for both joggers. So next, we can factor out t. So what's left is VA plus VB is equal to pi d. Now, let's clarify all the variables that are present in this equation because maybe some of you might think that, oh, we have lots of unknowns here. So maybe we still need to find another working equations. But as you notice, VA is given and VB is given and also our D. So therefore, for this equation, we only have one unknown, which is the time t. Our pi, we have a value for pi, which is an irrational number. Okay, so we are going to solve the value of our t here. So we have t times VA plus VB is equal to pi d. So we can divide both sides by VA plus VB. So this one is VA plus VB. So cancel out. We have t is equals to pi d over VA plus VB. Okay. From the previous slide, our d is we're going to use the zero point 0.8 kilometers. So you have pi times 0.8. So this is in kilometers. And then our VA is 3 kilometers per hour. And then our VB is 4 kilometers per hour. So we have 3 plus 4. So this one is in terms of kilometers per hour. Now, the reason why I include the units so that you will be assured that uh, you will arrive the correct unit for your final uh, answer. So just for assurance. As you notice, kilometer will be canceled out. So what's left is 1 over hour. So that will in turn um, result to an hour. So the resulting unit for our final answer is in terms of hour or hours. Okay, so we are going to evaluate this one. Pi times zero point 0.8 divided by 7. So if you're going to use your calculator, that is pi times zero point 0.8 divided by 7. That is 0.359. So you have 0.359, approximately 359 hours. But our final answer is in terms of minutes. So we are going to convert this unit, this hour, into minutes. So we have a conversion that 1 hour is equal to 60 minutes. So cancel out the hour. So our t is equal to, so times 60, you have approximately equal to 21.54 minutes. So this is the time it takes for both joggers um, to meet, no, within the circular track after they have started at the same point on the same track. Okay, so that is our final answer for our first uh, sample problem. Next, we will proceed to problem number 2. So we have here a car can travel from A to B, as shown in the illustration, a distance of 100 kilometers at an average speed of 30 kilometers per hour. So the distance from A to B is 100 kilometers. Okay, so at what average speed must it travel back from B to A in order to have an average speed of 45 kilometers per hour from the round trip of 200 kilometers? So first things first, if you encounter a motion problem, make sure to illustrate the problem, just like what I have here. So we have a car travels from A to B, and then from the problem, it also states that we need to get the average speed from traveling back from in traveling back from B to A for a round trip of 200 kilometers. So I guess this one is true. It's because the distance from A to B is 100 kilometers. So the round trip will be from A to B and then from B to A. So that is all in all 200 kilometers. Okay. Once you have the illustration, the next step is to um, indicate the given parameters or the given variables. So um, we are going to represent the distance of 100 kilometers with small letter d sub a b, and of course we all know that the distance also from b to a is still the same, which is equal to 100 kilometers. Next, from the problem, it is also stated that the speed of the car in traveling from A to B is 30 kilometers per hour. So we can represent that one as V sub AB, that is equal to 30 kilometers per hour. Next, um, we also have an average speed of 45 kilometers per hour for the round trip. So we can represent that one as the total average speed. So that would be 45 kilometers per hour. So this is in going from A to B and then back to A. Okay. So I guess that's all for the given parameters, because the this 200 kilometers is just to just to verify that the entire run trip, the distance is the sum of the distance from A to B and from B to A, and that is 200 kilometers. So solution. Now, since this problem involves the concept of average speed, so we are going to use the working formula for average speed. So again, the average speed for an entire trip or for a particular trip is expressed as the ratio of the total distance traveled over the total time of traveled. Okay, again, since we're talking about the average speed for the entire round trip, so in our given, we represent that one as VT. So that is the total distance for the round trip. So that would be D A to B plus D B to A. And then the total time of traveled, let's just represent that one by another variable. So that is from TAB, that is the time it takes to travel from A to B, plus the time in traveling from going back, so from B to A. Okay, so in the numerator, the distance from A to B and the distance from B to A are the same, and that is equal to 100 kilometers. So if we sum up, that is equal to 200 kilometers. So 200 kilometers. So we already have a value for our numerator. The problem here is that we don't know the time, no, in traveling from A to B, as well as in traveling back from B to A. So that is why we need to find a way to express this variable in terms of the given parameters. Okay, so that is TAB plus TBA. So same with the previous example, this will be our working equation. So where do we get this one? From the a basic principle of the average speed, and then where do we get the expression for the sum of the time? So we get this one by the analyzing the equation, and then and also through our illustration. Okay, so um let's proceed to the next slide because we don't have enough space for our solution. So we have VT is equal to, again, 200 kilometers. This is the total distance traveled for the entire round trip. Then we have the time from A to B, then plus the time from B to A. Now, after having this working equation, the next step is to use the basic formula for speed. So we all know that speed is equal to distance over time. Since in our equation we have the time as our variable, so we're going to get the expression for the time t in terms of the speed v and the distance d. So we take the cross, we do cross multiplication. So that is d is equals to vt. Then we divide both sides by v. So you have t is equal to distance over the velocity. Okay, so we are going to apply this one to our working equation. So the V total is equal to 200 kilometers divided by the time from A to B. So in terms of the distance and the average velocity, so that would be the distance from A to B over the average velocity in traveling from A to B, plus same with the time from B to A. So that is distance from B to A all over the velocity in traveling from B to A. Again, let's go back to our previous slide. The requirement here, sorry, we forgot to write the requirement of the problem. So that would be the average speed, no, in traveling back from B to A. So that would be V B A. So that is our unknown. So go back. So this is our unknown. Now let's check whether all the variables here are already have a value from our given. So VT, we already have a value for our VT, that is 45 kilometers per hour. For our DAB, so we already have a value for this one, as well as the VAB, which is the average speed in traveling from A to B. So therefore, we are good to go because we only have one equation and then one unknown. So the challenging part right here is to simplify this one. Okay, so VT is 45 is equals to 200, then all over the distance from A to B is 100 over the average speed in traveling from A to B is, I forget the value, that is okay 30, then plus 100 over this one is the unknown, so VBA. Okay, next, in our denominator we can factor out the 100 from the two terms. So we have 100, then what's left is 1 over 30 plus 1 over VBA. And then 200 divided by 100, so that would be 2. So 2 over 1 over 30 plus 1 over VBA. So we can take cross multiplication, so that would be 2 times. Again, do not forget to put a parenthesis since the operation is multiplication. So that would be 1 over 30 plus 1 over VBA. Okay, next is we're going to multiply this one. So you have 2 is equals to 45 over 30 plus 45 over VBA. Now, in order to eliminate the fraction, so we can multiply both sides of the equation by 30 VBA. Okay, so multiplying this one to each of the terms in the equation, so that would be 60 VBA is equal to 45 VBA, then plus 45 times 30, that would be 1350. So 1350, um, that is the product, no, for the last term. Next, combine the unknowns, so that would be 60 minus 45, so that would be 15. Okay, 15 VBA is equal to 1350. So divide both sides by 15. So VBA is equal to 90. Okay, 90, and then the unit is kilometers per hour. Okay, so you can also check whether your units are consistent um, by performing the dimensional analysis, no, or dimensional check. So let's go back to um, our working equation right here for our average speed. So on the left side, we have the average speed, no, for the entire round trip. So that is in terms of this one is in terms of kilometers per hour, and then in the numerator, the 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 unit is kilometers, and then on the denominator, we assume that this is in hours, so so therefore we have a consistent unit for both sides of the equation. Now how about for the time? The time is expressed in terms of distance over the speed. Now if we try to check also the units here, so the distance from the given, that is in terms of kilometers also, and then the average speed is also expressed in kph, or kilometers per hour. So therefore kilometers will be cancelled out, then what's left is the hour. So therefore we have a consistent unit for each of our parameters that is present in our working equation. Okay, so let's proceed to the last problem. So problem number 3. An airplane flying with the wind took 2 hours to travel 1000 kilometers and 2.5 hours in flying back. So the question is, what was the wind velocity in kilometers per hour? Now, this is under the uh, the two key points that I have just discussed to you from the previous slides, wherein we have an object in our problem, an airplane, and then this airplane is flying on a particular medium, that is wind or in air. So this air is moving with a certain velocity, that is our requirement for our problem. So therefore we are going to use those analysis in solving this problem. So first things first, in motion problem, make sure to illustrate the problem. So illustration. Okay, let's assume that this airplane is flying from uh, points A and B. So this is point A and this is point B. So the distance from A to B is also stated in the problem, that is 1000 kilometers. No? So it took this airplane 2 hours to travel 1000 kilometers if it flies with the wind. So this one is 1000 kilometers. Okay, so the the direction of our wind is, we assume that one from A to B. Okay, so this is direction of our wind. So that is the velocity of our wind, VW. Okay, that is unknown. Then this is our airplane. So in the first case, it travels with the wind. So let's say this is our VO. Okay, this is our airplane's velocity. So from A to B, the time, so that is TAB, is equal to 2 hours. Now, if it travels back from B to A, so for the second case, this one, so second case, uh, the direction of its speed or its velocity is towards the left. So this is our VO, and this one is against the direction of our wind, which is towards the right. So therefore, it took the plane half an hour more than it took it in traveling from A to B. That is why the total time is 2.5 hours. So we have an additional of 0.5 hour for the time. Okay, because it travels against the wind. Okay, so after the illustration, again, the given are already shown in our illustration. So let's proceed to the requirement of the problem. So the unknown is the wind velocity in kilometers per hour. So that would be VW in terms of kilometers per hour. So solution. Again, the answer for this problem is 50 kilometers per hour. So let's verify. So solution. We have uh, two cases or two scenarios that happen in our problem. That is the airplane flying with the wind. That is our first case. So airplane flying with the wind. Okay, so if the airplane is flying with the wind, so therefore the resulting velocity is the sum of the airplane's absolute velocity, and the wind velocity. Okay, so we all know that um, velocity is equal to the distance over time. Okay, so for this first case, our result resulting velocity is represented by vr, and then our distance is from a to b, and then our time is also represented by tab. So the resulting velocity is equal to the sum, so that would be um, vo plus vw is equal to the distance from a to b is given, that is equal to 1000 kilometers, so we have 1000 all over the time from a to b, that is 2 hours. Okay, so if we do unit analysis, the numerator is in terms of kilometers, then the denominator is in terms of hours. So it is expected that um, the units for the velocity on the left is in terms of kilometers per hour. Take note, VO, V sub O, and V sub W are unknown variables. Okay, so this is our equation 1. Next, we will proceed to the second case, and then we're going to write this one in this slide. So the second case is that the airplane flying against the wind. Okay, if that is the case, then the resulting velocity or speed of the airplane is the difference of its absolute velocity v sub o and the wind velocity. So vr is equal to the distance, but this time that is from b to a over the time from b to a. That is v sub o, that is for the airplane's velocity, and vw, this is for the wind velocity. Then the distance from b to a is uh, equal to the distance from a to b, that is 1000. Then the time is 2.5, so it took the plane much longer because it flies against the wind. So this is our second equation. So if we're going to list the two equations on this slide, so again for equation 1, that is vo plus vw, that is equal to 1000 over 2. So first equation, then we have vo minus vw, that is equal to 1000 over 2.5. Okay, this is our second equation. Now, as you notice, we have two unknowns, vo and vw, and we also have two equations. So therefore, we can solve uh, this system of linear equations by using your scientific calculator or by manual solution. So let me show you the calculator technique. Okay, So go to mode, choose 5 for equation, and then select 1. This is for two equations, two unknowns. So let's start with equation number 1. Let's plug in the coefficients of the variables. Now take note, in using this feature in your calculator, make sure that you properly arrange all the unknowns and the constant. So the unknowns should be on the left side, and then the constant should be on the right side. And make sure that for every equations that you have listed, make sure that you have a uniform arrangement of your unknowns. That is, if you start with VO for your first equation, then you must do the same for the rest of the equations. So VO is 1, then 1, then here 1000 divided by 2. Then for the second equation, we have 1, the negative 1, and then the constant 1000 divided by 2.5. Okay, are equals. So our x, which is VO, that is the airplane's velocity, is 450 kilometers per hour. And then our VW, which is our wind velocity, is 50 kilometers per hour. So therefore, by using scientific calculator, we found out that the airplane's velocity is 450 kilometers per hour, and then the wind velocity is only 50 kilometers per hour. Okay, now we can also solve this one by manual solution. So um, we can solve for VO on equation 1 in terms of the constant and the wind velocity, and then we're going to substitute this one to VO on the second equation, so that what's left is only an equation that contains the VW alone. Okay, so let's do that. In equation 1, so VO is equal to 1000 divided by 2, that is 500, and then minus VW. So we are going to substitute this one to VO on our second equation. So in our second equation, we have VO minus VW is equals to 1000 divided by 2.5, that is 400. So VO is equal to this one. So we have 500 minus VW minus VW is equals to 400. So combine these two, that is negative 2VW, and then transpose 500 on the right side of the equation. That would be 400 minus 500. So divide both sides by negative 2. So we have VW is equals to 400 minus 500, that is negative 100, divided by negative 2. So that is 50 kilometers per hour, which is still the same with the answer from our scientific calculator. So that's it. This is our final answer for this problem. Now let's see the magnitude of the effect of the wind if we fly with the wind, or if we fly against it. So with the wind, let's uh, let's evaluate the resulting velocity. So the resulting velocity again is equal to the sum of the wind and the absolute velocity of the plane. So that is 450 plus 50, that is equal to 500. So as you notice, if there's a tailwind, so we call that one as a tailwind if we have a wind that blows from the rear to the front of the plane. If we fly against the wind, okay, against the wind, if we fly against the wind, so the resulting velocity of the plane is only 400 kilometers per hour. So there is a reduction from its absolute velocity of 450. Unlike if we travel with the tailwind, So we call this the tailwind from the word tail. So the wind blows from the rear part of the plane towards the front. But if we travel against the wind, we call that one as the headwind. So the wind comes from the front of the airplane. So if that is the case, then our absolute velocity of the plane reduces from 450 to 400 kilometers per hour. Okay, so see, there's a drastic amount of reduction of the uh, resulting velocity of our airplane due to the effect of the wind velocity. Okay, so that's it for this video. Thank you and God bless.